So I'm going to take you through the three PoCs that I mentioned in the previous video. So as discussed, the first one is touching on the foundation of the proposal, which is taking all the logic out of the connector and taking the data, and instead taking data that we get out of our CRUD transaction queue or mutation queue and sending them as is over a predefined protocol and sending them to the backend. I didn't mention this in the previous video, but one of the benefits of adopting some IDL like OpenAPI is that we can easily generate our client and our server handler code for a given endpoint, which is very nice. And if we consider that PowerSync supports a very wide set of SDKs as well as client SDKs and databases, it means we can support almost any backend language and any of the languages that we support on in the client side. So being able to generate some of that code for the backend specifically is very useful, and it makes it easier for us to support all the permutations that we want to be able to support. So there's a little PR description just going through with a chart that shows kind of the flow of how data change or data goes from the client to the backend. So I'm going to quickly go through the demo connector chain or the connectors changes, what the code looks like for the generated code that we're using to now transport the code from the client through the protocol to the backend. And then some of the basic, because this is a JavaScript or TypeScript example, we'll just use an express middleware that's riding on the OpenAPI spec on the backend. And we'll call a little function to just take the data, map it, and then persist it. For this example, I'll just follow the Postgres path, but this PR does touch on the other source databases as well. So I guess the first and foremost, most important thing would be to look at the OpenAPI spec that I introduced. So just a basic OpenAPI spec. We're defining a API data endpoint, and the request body is of type CRUD transaction. For now, I'm just doing this one slice, but we can obviously also support batches and multiple transactions as well, which is something that has been discussed. I've added the checkpoint part here, but we can ignore this for now. So this is what the CRUD transaction looks like, and this is very much, a CRUD transaction is basically just an array of CRUD entries. And this is very much just the structure as is that we get from the client when we pull a CRUD entry from the queue. Nothing new here, but we might add some extra stuff here to actually enrich this type of endpoint that we are now considering to support. And if I guess the most noteworthy thing, this is just a basic node demo, but the most noteworthy changes would be in the demo connector. We still have fetch credentials, that's standard. We have this upload data, and this ideally becomes very, if we adopt something like this, it becomes very standardized. So we get our next transaction, we might get a client ID, we prepare a write client, which is basically just a wrapper around the OpenAPI generated code that we have. And with this client in hand, we can just call process transaction, which is the endpoint we have that's been generated. And that just takes the transaction as is, and it pumps it through. And if the result from our backend is successful, we'll just call complete. Otherwise, with the OpenAPI spec, we've introduced two error types. One is a fatal error, which we can't do anything about. And the other one's a retriable error, which basically just, for fatal error, you might want to handle it in some manner for now. So in the future, we might have something like a dead letter queue implementation for the backend that we recommend that allows us to move on when we reach certain types of errors. So basically it becomes, instead of the client having to continuously try to get this thing to be resolved, the backend is in charge of resolving certain types of errors. And then the other type of failure is a retriable failure, which basically just means, maybe the network was down or there's some transient error that we're pretty sure if you keep on retrying, it will go away. So just keep on retrying. We can look at some of the code that's generated, that's wrapping the generated code. This is very standard. This is all just some types for the client that just makes it easy to, it's just like doing the basic mapping from whatever the types are that we get from the cron transaction, and just preparing it for the Open API transport, and that's all that this is basically doing. And then that's basically all we're using to, I guess the other interesting is that you could technically call these operations directly instead of like depending on the upload data flow to do that. I just added that as an interesting thing, but it's not something we're sure we're going to adopt. But being able to, I guess the idea there would be like being able to call write directly instead of depending on the full PowerSync client-side flow. It could be quite nice. So then for the backend, what's interesting here, we register, let's say, this data entry or this data endpoint, and it's very straightforward, just using OpenAPI's types, and we have a little piece of logic here that says, okay, we've handled the endpoint, just go through the flow, and update batch will then trigger two pieces of code. The one is, I guess it's preparing the persister to persist the data, and the other part is the mapper. So for Postgres, the basic mapper would look something like this. And this is good enough to pass on to the persister, which this is like, the best way to explain it is this is ideal for scenarios where the data mapping between the SQLite and Postgres is basically one-to-one. And where you would have derivatives for, say, custom types or other pieces of logic, we could then extend this or have other implementations that handle that. For things that we know are very common, we could introduce like standard column mappers, like for the geo-based columns, for example. And then if you look at the MongoDB persister, it's just slightly different. But I think for the default would work for Postgres and for MySQL and MS SQL quite well. So this is the essence of the first POC and what it touches on. It is very rough, but it is like just introducing the ideas that I think we would love feedback on. So if we go to the second PR, which is this idea of a mutator pattern, basically there's a school of thought that pushes the idea of, I want to say, almost segregating or taking a step back on how the data flow happens, and instead of everything going very explicitly through like the upload datas, like having mapping logic, etc. We define a mutator on the client and a matching mutator on the back end, and they correspond. So the mutator on the client is responsible for when you call it makes a change against the SQLite database locally, and with that change on the SQLite database, it's also storing metadata about the mutation. So like storing what was the mutation that was called, and what is the arguments that we use for the mutator. And instead of that information, instead of the database changes being the useful information that we pass to the backend, the more interesting piece of information we want to pass to the backend is actually the arguments and the mutator that was called. So we can then use those arguments on a dedicated mutator on the backend. So that might sound like a lot of effort, but in some sense it may make certain implementations for the right path simpler. So if we look at this code example, what that would look like, what the usage would look like on the client is we have a mutator defined somewhere, and we call it like this, and we just give it the arguments. The mutation definition on the client side is this. We've defined what the arguments are via Zod, via like a Zod typing, and the actual list create mutation on the client side has a run function and has the args, and we call a SQLite query or write query against the database with these args and the metadata, and that's good enough to have the local change happen. And then in the upload data, all the upload data is doing is, it's very standard. It's just taking that metadata information and sending it up to the backend. And then on the backend, the code that's been written here links up to the corresponding backend mutator. It takes those args and applies it to a query that's implemented as is on the backend. and this is specific, and you would have your implementation of the mutator for the backend would be specific to your source database. So it does seem like it's like a very round the bush way of going about things, but you might think that this makes it easier to handle if you had complex type mapping, for example, or your logic was different. This could be very helpful. We don't have to map the CRUD data that's been changed and figure out how to get that into the database. We just take the arguments of the mutation and apply it. So I don't know what's beyond what's in the usage and in the PR description. What would be more would also be useful to show. Potentially, the demo connector is anything that's actually different. So the upload data implementation, instead of just calling the generated OpenAPI spec, we have a different OpenAPI spec that we can work off of, where we introduce a very standard mutators invoke endpoint, and then everything can just instead of depending on the original API data endpoint from the previous PR, we could just depend on this. And then we know all mutations have a very similar shape, and we can just go through that. And then the backend, if you look at the code in the backend, it's written to be able to handle that mapping. With the demo connector code, in this example, we still allow you to process transactions in the normal way if you want, if you didn't write a dedicated mutator. But if we detect that the CRUD entry has metadata that says, listen, I'm a mutation, I have args, we go down a different data path. So this was basically the mutator pattern, or the idea of it. I'd love feedback on this specifically, because this might not be useful for everyone. I do think it might be powerful for some users though. And then the third demo isn't really introducing a lot of novel ideas. It's just building on the first PR or POC. It's just taking that one step further and trying to wedge all that logic into a Superbase Edge function. And we do this because maybe you don't want your mapping logic to be in the client, you want it to be on the back end, and maybe you want rollbacks and transaction support for your mutation path, which you don't have if you use Superbase, the Superbase SDK at the moment. Some of the recommended workarounds for that at the moment for existing users, but this approach allows us to apply the same demo connector changes, which are very simple, and then just also handle it, but instead of handling it through like an express handler, we handle it through the Superbase Edge function. So I don't know if there's a lot to show here that'll be interesting. Let's say we have this endpoint. No, it's an index. So basically just very similar to the express code that we had. We're just handling, we just define an edge function here as under functions /data. The demo connector, instead of the demo connector hitting an OpenAPI endpoint, it's actually just calling the edge function. I'll show that in a second. And we're still depending on the OpenAPI type definition for the validation, which is very nice. And then we just call it, and we go through the exact same flow as you had for the first POC, where we then map the data and we try to persist it, and we persist it. This entire thing goes through a PG or Postgres persistent instead of using the Superbase SDK specifically. So if we go to the demo connector, this should be very familiar. Source, navigation, providers. Okay, Superbase connectors. This is like very similar to our existing Superbase connector that we have for other demos. Except we're just translating the CRUD transactions from as we get it from the CRUD queue, and just mapping it to the request body, and then we just invoke the data RPC, and then we handle success, fatal errors, and retriable errors in the very same way as the first POC. But this was a very high-level overview of the ideas that I've been looking into. I would love any feedback or ideas. if users feel that this potentially alleviates some pain points, please let us know. If there are things that this doesn't cover or makes worse, we would also love that type of feedback. We're trying to make it easier for users to adopt and extend our PowerSync usage. But yeah, thank you for watching, and I hope you enjoy the rest of your day. Bye.